This video shows how to quickly get started with Proteus and Arduino. It is split into 3 chapters which can be navigated from the tabs at the top of the video. You will need a Proteus license for either the AVR family or for the Arduino product to simulate these designs. Starting from the New Project wizard, select the appropriate Arduino processor shield and name your project. This initializes the project with the processor shield on the schematic and a skeleton firmware project in the VSM Studio IDE. If the Arduino toolchain is not installed, it can be downloaded via the compiler's configuration dialog in VSM Studio. After installation, the recheck button will configure the Arduino toolchain for use with Proteus VSM simulation. Next, we need to bring in some peripheral shields to the schematic. Several are pre-supplied as project clips, and you can create your own by placing and connecting up the required components. Terminals with the same name are just like wires connecting the pins together, so placing the project clip on the schematic is exactly like plugging in the shield to the main board. On the firmware side, the first thing to do is include the Arduino library. Note that the chevron syntax around the included file is important to distinguish it as an Arduino header file. After that, initialize the LCD with the numbers of the interface pins. Then add a little test code in the setup routine. Compile the program from the Build menu and press the Play button to run the simulation. You will see interactive areas of the schematic inside the IDE, with the LCD correctly displaying the characters we sent. If we pause the simulation, we can select our source file and debug the code. Set a breakpoint at the entry of the setup routine. Run the simulation, then use the Reset button to reset the processor. The system will pause at the breakpoint so we can single step through our code, watching the output on the right hand side of the screen. We could, if we preferred, also view and single step at assembly level. While we have been using active pop-ups to work with parts of the schematic inside our IDE, we can just as easily switch tabs to the full schematic during simulation. We can now add a little more example code to switch text between lines into the main loop function. Recompile the program and run the simulation to view the results. Clear any existing breakpoints so that we can free run the program. The simulated LCD shows that everything is working as we would expect. If we pause the simulation, we can step the code and walk through the loop routine. Note that entries in the variables display will highlight on change. Diagnostic messages allows us to ask questions of both the peripherals and the processor during simulation. In this example, we will request full information from the LCD display controller. Stepping through the code again, we can now see a text report from the LCD model, informing us when a command has been received. Proteus also gives you a full set of instruments for debugging on the schematic. If we switch to the motor control sample design, we can see that we have the motor control, the terminal, and the button keys shields present. The buttons increase and decrease the speeds of the two motors, and the terminal acts as a console dump. Let's place an oscilloscope on the wires of interest to monitor the mark-space ratio of the PWM signals. Delete the shield boundary graphic and then connect up the A and B channels of the scope to the PWM lines. When we run the simulation, we can see that as we press the button to increase the motor speed, we are increasing the duty cycle of the PWM signal and vice versa. If needed, we could then pause and single step the code in the normal way.